by releasing a lot of methane into the atmosphere, it would be highly risky, as you can see from our climate simulations. I'm Lievke Cesar, I'm a climate physicist and I'm also a science fiction lover. And this book, Project Hail Mary by Andy Weir, you might have heard about it because it just came out as a movie with Ryan Gosling, really made me wonder, does the climate physics check out what would happen if this scenario were to happen in real life? Now, to just basically, for those of you who haven't watched the movie yet or read the book, get you into the story. What happens is the sun is dying, and Earth basically sends out an astronaut to find a cure, but they do know the astronaut is going to take approximately 26 years at the least to come back. At the same time, the sun continues to die, the Earth is going to cool a lot, so the humanity actually decides, okay, let's try to interfere with that, let's try some climate geoengineering and put a lot of greenhouse gases into the atmosphere to counteract the cooling, actually nuking Antarctica. The book is actually somewhat specific in parts, but before I get into the details, let's talk about what sets the temperature of the Earth. Well, this is actually a very simple energy balance equation. Energy in equals energy out. Now, specifics are a little bit more complex, so you can see that here in our equation. On the left-hand side, we have the energy in, that is set on the one hand side by the solar constant, so how much energy is emitted by the sun, and it's also set by the alpha value, which is the albedo of the Earth, that is how much energy is reflected directly by the Earth. Just knowing that, for example, snow and ice often reflect sunlight way better than a dark ocean or a forest. Now on the other side, the right-hand side, we have the energy out, how much energy is emitted by the Earth. That is determined on the one hand side by a physical law, the Stefan Boltzmann law, saying that all matter that has a temperature above absolute zero actually radiates energy, proportional to the temperature to the power of 4. We have some constant in there. And then we also actually normally add an emission factor. That is, while a body radiates energy, the question on how good that is radiated away depends on basically the barrier that is around it. For us humans, it would, for example, be our clothes, which is why when we put a lot of clothes, we get warmer. For our planet, it's the atmospheric layer. Now, when we look at the atmosphere that is filled by different gases, some of them actually don't do a lot, like nitrogen or oxygen, apart from that we need it to breathe, but some are rather active, and they actually interact with the infrared radiation emitted by the Earth, take it up, re-emit it partly back to the Earth, and therefore they warm the planet. We call those gases greenhouse gases. You've probably heard about them. On the one hand side, we have the very famous CO2, which is causing us quite a lot of problems, but there are other ones. Water vapor is actually acting as a greenhouse gas. Methane is another one. Now, the greenhouse gases are not all the same. They interact on slightly different light flavors, light wavelength, and they also have different times on how long they stay into the atmosphere. And this brings us back to the book. Now, in their book, they know or they hope that actually there is going to be a cure after 26 years. More or less. So they think, okay, let's put something in the atmosphere that actually doesn't stay forever. CO2 stays in the atmosphere for a very long time. Now, methane, on the other side, actually has a lifetime in the atmosphere that is only a couple of decades, sometimes even far less. So the idea is, let's put a lot of methane into the atmosphere to counteract the cooling, but if we do find a cure, then we just stop putting methane into the atmosphere, and it only takes a couple of years to actually fall out. Now, what would work about that is that, yes, we actually do have a lot of methane on Earth, especially under Antarctica. There are large reservoirs of methane. And what they do in the book is they nuke Antarctica to try to get that methane out. And yet, methane only stays in the atmosphere for a couple of years. Now, the problems are, we read some papers on how much methane is beneath Antarctica, and there's quite some uncertainties attached to that. There are estimates of a couple of tens of petagrams. Petagram is 10 to the power of 15 grams to maybe a few hundreds. Just comparing that to the current amount of methane in the atmosphere is only about 5 to 6 petagrams, so there is a lot of additional methane below it. But it is below kilometers of ice, below the bedrock, so it's actually pretty hard to get to. And nuking that is also not a very controlled way of knowing how much methane is going to be released. But now, back to the book. We actually ran a couple of climate simulations in our spare time to see how plausible are the scenario in the book. We ran 4 simulations to see what could happen if humanity is encountered with this scenario of the sun dying and tries to do something about it. As a control scenario, in blue you can see the scenario where the sun is dying but we are not interacting with the Earth's climate. This would lead to a severe amount of cooling. But if the astronaut comes back after 26 years finding a cure, we actually can go back to our before temperatures within a few decades. Now, if we put some methane every other year into the atmosphere by nuking Antarctica, we can counteract this cooling a little bit, but it's really only a little bit. As you can see, we still have a couple of degrees of global cooling in the mean, which could lead to much more cooling locally. But again, finding the cure will actually get us back to okay temperatures after a few decades. Now, if humanity becomes more desperate because we do see this cooling coming due to the sun dying, we put a lot of methane into the atmosphere. Then what we actually see is, yes, we can counteract the cooling more. We still have net cooling, but because methane breaks down into CO2 in the long term, we end up, after the astronaut comes back with a cure, with actually 4 or 5 degrees of global net warming, and with the consequences that come with that. Just compared to today's climate, at the moment we are at about 1.5 degrees of global warming, so a world with 4 or 5 degrees of global warming would be catastrophic. And then lastly, of course, we checked that if the astronaut would not come back with a cure, or not send us a cure, then even all this amount of methane wouldn't change us because the sun is such a powerful player. Now, in summary, from a climate physicist perspective, there's actually a lot that the book does right. It is a plausible scenario that if the sun were gonna die, then we would have measures of trying to counteract that by releasing a lot of methane into the atmosphere. It would be highly risky, as you can see from our climate simulations. So, in summary, a lot of the climate physics behind the book actually checks out. If the sun were going to dim, we could try to counteract that by playing with the Earth's greenhouse gases and putting more of them into the atmosphere. But as you can see from our simulations, it would be very, very difficult to actually really control the Earth's global mean temperature. We couldn't end up either way with a lot of cooling or way too much warming in the long term. So I wouldn't advise to play with the thermostats of the Earth. This would be my please don't do this at home disclaimer here. But I do hope that this is not going to stop you from watching the movie. I'm actually quite interested now in seeing how Ryan Gosling is going to deal with this situation. Otherwise, if you just want to learn more about the Earth's climate and also why we actually don't just care about climate, but also the integrity of the biosphere, the state of our freshwater cycles and more, please check out our website on the planetaryhealthcheck.org or also look at the video description for more information.